Hey programmers, Alvin here. So lately I've been working a lot on data structures and algorithms, and I know I haven't posted a video in quite some time. It is, of course, the holiday season, so I figured a nice way to kind of merge the two would be to work through the Advent of Code contest. So if you're unfamiliar, Advent of Code is a nice coding challenge contest where basically they're going to trickle out a new data structure and algorithm problem every single day, and it does get progressively harder over the month. So we will, of course, be using a lot of data structures and algorithms. It does start relatively easy, but as we go further, we're going to have to probably optimize our solutions in terms of their time and space complexity. And I think I'll implement all of my code in JavaScript, but that being said, I'll be sure to maybe present a general algorithm that you can translate into the language of your choice. So with all that out of the way, let's just hop into day one. So naturally, we have spoilers ahead. So if you haven't given this day one problem a shot yet, you'll definitely want to head to the link and give it a try first before you watch this little video. So I'll present the problem with all of its story elements removed. So we're going to save the cute narrative for now. So you're going to be given basically a list of some numbers, and what we want to do is really figure out the pair of numbers in this array that sums to the target 2020, the year of infamy, of course. And so in this particular input, now that would be these two numbers, right? If I took the sum of 1721 and 299, that does indeed equal 2020. Something to actually add to this problem is instead of just returning the pair of numbers, you want to actually return their product. So although their sum is 2020, I want to return the product of those two numbers, which would be this 514,000 number. So that's probably a little contrived part of the solution. We can probably just focus on getting the pair of numbers in the first place. It's a very popular interview problem. So how can we come up with a strategy for that instance? Well, I think it's okay to maybe just lay out or at least talk about the naive solution, and then we can adjust it to maybe get a more efficient solution. So of course, if I want an algorithm that finds a pair of numbers inside of the list, then I'm going to have to iterate through the list. So let's say we start iterating through our list. So once I'm at some position of my list, I want to compare that element to basically all other elements of the array, and then check if they sum to 2020. Well, since I want to compare this element to all the other ones, I could just start a nested loop. Naturally, I want to make sure that this nested loop doesn't look at maybe duplicate pairs, so I don't want to compare 1721 to itself. Instead, I can come up with some logic to maybe look ahead by one space in the array. So this is really just a classic nested loop pattern. So this would definitely iterate through all possible pairs of elements in my array. And I just want to check some conditional along the way. And that's a very, very straightforward solution. That being said, what would the efficiency be of that solution? Well, you might probably notice that since this uses nested loops, my outer loop is just going to iterate through the array, and it's also the case that my inner loop is roughly going to iterate through the array as well. So that would be an n times n, or n squared time complexity. This is indeed a very common interview problem. It is considered an easy one, and I think that most interviewers would probably not be super duper happy with the n squared solution because it's very, very easy to implement. And so instead of doing that n squared solution, how can I improve this solution? Well, I think where we can start is to recognize maybe what's the fastest we can ever get this algorithm, in theory. Well, I know I can't find a pair of elements in the array without looking at least every element once, right? So I'm basically striving for a solution that's at least O of n, right? And I know that my current n squared solution suffers because I have to look through all elements of the array for every element of the array. So maybe I can get rid of that inner loop. And the trick here is to use some efficient data structure that can remember what elements you've seen before. So that means some sort of a hashed data structure. For me in JavaScript, that means things like JavaScript objects or even sets and maps in JavaScript. All right, so now let's plan for this improved algorithm. Well, I'll start by just initializing an empty hash set, so it contains no elements. Then I'm going to start iterating through my array of numbers. Once I'm at some number, I know in the long run I want to find a pair of numbers that sums to 2020. So what I can do is take 2020, subtract my current number from it, and it'll give me some resulting number. What I want to do is check, is this resulting number in the array also? But I don't want to just start another linear search by using another for loop. Instead, I'm going to leverage my set. And so what I'm going to ask is, hey, for this partnering number of 299, is that inside of my set? Right now my set is empty, so that's false, right? 299 is not in my set. So what I should do is just go ahead and add my current number, which is 1721, and add it to my set. My set is going to represent all of the numbers of the array that I've seen previously. So on the next iteration, I'm at 797, and I take the difference. I check, is 1041 inside of my set? It's not, so I can just add 979 into my set. Next iteration, I have 366. I check, is 1654 inside of my set? It's not, so I can just add the original 366. And then things get interesting on this next iteration. My current is 299. If I take the difference, that means I have 1721. And I check, is 1721 inside of my set? And that's actually true now. And because it's true, that means I found some pair of numbers whose sum is 2020. Then at this point, all of the rest of the work is pretty much academic. We just want to return the product of those two numbers. And so that would be our final answer over here. And if we do a quick spot check for the complexity of this, let's talk about it. So it seems that the time complexity is definitely going to be O of n, because I just used one loop to iterate through my list once. And then for every element of the list, I have to eventually store it in my set. So the set would also grow to be n space as well. So we're looking at linear time and linear space, which is a pretty efficient solution. So that seems pretty reasonable to implement. Let's actually head back into my editor where we can code this one up. So let's go about implementing this one together. Here I have my input downloaded. So this would be the list of numbers that I have to write my logic for. When you download this problem for yourself, you'll probably have a different input, which is all good. So I went ahead and started just some initial code that lets me just read contents of this file. You just want to write the similar pattern in your language of choice. So I just have this nice parse lines function. So maybe in this function, my main function where I'll solve the problem, maybe I'll just call parse lines and then we'll start there. So if I call parse lines, it's just going to automatically read from the input file. Let me actually get that information. Then I'll just go ahead and print it out. So I'll call this my lines. And since I'm using await here because reading files for me right now is going to be asynchronous, I'll go ahead and make solve an async function. If you're familiar with some JavaScript. Not really important to the algorithm though. Let's just go ahead and see what lines looks like. So I'll go ahead and run my starting code. So it's part1.js. So there I see an array of every single line. One thing I notice is by default, this is going to be string data. So I guess I should convert all of these into some numbers. So I'll really begin by taking all of those lines, turning it into some actual numbers by mapping over each of them and just passing them into the number constructor. So that's how I can convert just all of the elements of this array from string to number in JavaScript. Nothing too fancy so far. All right, so now that I have that pretty large array, let's go ahead and implement our main algorithm. So like we mentioned in our strategy, the key to victory here is to use some fast lookup data structure like a hash table, right? For me, that means I'll create a JavaScript set. So I'll say my number set equals a new set. Really, you just want to use the structure in your language of choice that gives you constant lookup, right? So constant time lookup. So if you're unfamiliar with the JavaScript set, let's say I created one just in my node REPL to play around with. So I can create a set, and then over time, I can add members to this set by just using the .add method. So let's say I add 4, I also add 5, and also add 10. So those are the members of my set. A few characteristics of a set, and very similar to many hash data structures. If I try to add a duplicate element like 5, that would be adding it twice over. Sets will give you only unique elements, right? But I can always check if someone is inside of the set by doing numberSet.has. I can pass in the thing I'm looking for. So does my set have 10? That's true. Does my set have 4? That's true. Does my set have 12? That's false. And the important thing here is all of those lookup operations runs in roughly constant time, right? So now that I have my number set, let me iterate through every element of the numbers array. So I'll do for let number of numbers. So that gives me every element of that array. And what I want to do is check if this number's partner is within the set. So I want to calculate the difference here. So I'll say const, say difference equals, and I'll take the number 2020. That's kind of just part of the problem, right? You want to find all pairs of numbers that add to 2020. So I'll check the difference of 2020 and the current number I'm iterating through. Cool. And then from there, I want to check, in general, if that difference is within the set. So I'll check if number set has the difference. And if it has a difference, then I have just found a pair that adds up to 2020. So if that was the case, then I can return their product, right? Kind of a weird thing they have us do in the problem. So I can return the number that I'm iterating through times the difference. Nice. But beyond this checking logic, what I want to do is also add members into my set. So let's say I have this scenario where, all right, my difference is not within the set. Then I'm going to have to keep looking. But what I should do before I go on is add this current number into the set, right? So I can do number set dot add, and I'll add my current number. Really important thing here, you definitely want to add your current number into the set after you check your logic over here. And so with that, I think we're ready to test this code. So what I'll do to just see the output is I have an async function over here that's solve. So I'll run that function and then I'll print out the result. So if this is working, this should be the resulting answer. That would be the product of the two numbers that sum to 2020. Let's give that a quick run and we'll see what we get. So there it is running, nice, and there we have our solution. So nothing much to this problem. Like we said, in terms of the complexity analysis, we have a for loop here that's definitely going to run in O of n time, where n is the numbers in the array. And then, although this line 14, checks for the difference within the number set, that runs in constant time. So I have just overall O of n, time complexity, and then O of n space from storing things in my set, right? Over time, I'm basically going to be adding every number of the array into my set. And so there we have our solution for day 1, part 1. Let's head back into the drawing board. All right, now let's work on level 2 of this problem. So if you haven't given part 2 a shot yet, maybe pause the video, give it a go, and then come back to this walkthrough. And so in part 2, we have the same input, still going to be a list of some numbers, and our target is still 2020. However, this time around, what we want to do is find a triplet whose sum is 2020. So for this particular example input, that would be these three numbers, right? If I take the sum of all three of them, it is indeed 2020. But similar to version 1, we don't want to return the numbers themselves. We want to return their products. We just multiply them together. So our final answer should be this number over here. So how can we go about implementing this solution? Well, like you probably imagined, the naive solution would just be to use triple nested loops to iterate through all triplets of numbers and check if their sum is equal to 2020. But like you probably already noticed, that wouldn't give us the best complexity. In particular, that would definitely give us an n cubed time complexity, which in the grand scheme of things isn't like the optimal time efficiency to solve this triplet problem. And so let's say we're not satisfied with the n cubed solution. How can we do better? Well, I will say that there is a few different n squared solutions to this triplet sum, and I'll show you one of them over here. So the trick would be to not use 3 loops, obviously, but instead maybe focus in on using nested loops, so just n squared, and then using an additional storage mechanism. In particular, I want to reuse our hash table strategy. So I'm still going to use some fast lookup data structure to kind of overcome this efficiency. And so let's take a lay of the land and start building this algorithm. So what I'll do is I'll initialize some hash table. So depending on the language of your choice, that could be like Python dictionaries, JavaScript objects, any of those things. And it's really important with the structure that you choose. I think it's going to be helpful to have a key value pair mapping. So whereas before I used a set because I just wanted items, now I want a hash table because I want a pair, right? I want to associate some key with a value. And then now that I have my empty hash table, I'm just going to start iterating with nested loops through my input. So if I use my classic nested loop pattern, I would just grab 2 elements of the array. And what I can do is I can add them up. If I add them up, they give me some quantity, right? And what I should do is I should take this resulting quantity of, in this case, 2,700, and I'll make it a key of my hash table. And I'm going to make the value associated with this key the actual 2 elements that gave me that sum. So take a moment to notice the pattern, right? So the elements of my array that I'm iterating through with my nested loops are 1721 and 979. Notice that that becomes like the values inside of my hash table, and they belong to the key of their sum, which was 2700. So I can carry over this pattern for all other pairs that I iterate through. So I keep adding these sums as keys and make the values both of the numbers that led to that sum. And I'll just follow this pattern through. We're going to accumulate basically every pair sum into this hash table, and I won't list them all out, but at a certain point we're going to hit something convenient like 1041 points to 366 and 675, right? Again, I'm not listing every single pair sum here, but these are just the ones I want to pay attention to as we trace through the solution here. Cool. So we'd carry over this algorithm all the way through, and by the end of that like n squared runtime, I would have a complete hash table. But that obviously isn't my final answer, right? I've only looked at pair sums, right? How can I work in like the triplet nature of this problem? Well, we basically have all of the hard work done. So if I look at the rows of my hash table, I know that each of those keys represent a pair sum. So if I want to really analyze now triplet sums, I can just consider elements of the array once again. So I'm going to begin another for loop or another loop that just iterates through every element once. So this is not nested. So right now I'm pointing to 1721. What I can do is I can take that number and subtract it from 2020. Right? If I subtract it from 2020, then I get 299. And what I can do is I can check, is this 299 inside of my hash table? And in particular, I really want to know, is 299 a key of the hash table? So I don't really care if it's a value, right? In the long run, I want to establish some logic where I basically have found a triplet that sums to 2020. Remember that our previous pair sums were the keys of this hash table, right? So 299 is not a key of this hash table, so I can continue to my next iteration. So now I have 979, I subtract it from 2020, and I get 1041. And I check, is 1041 a key of my hash table? And it actually is. I can find it right here. At this point, that logically means that I found some triplet whose sum is 2020. How can I actually recognize that triplet? Well, one of the elements in the triplet would be the current number I'm iterating through, in this case, 979. And then the other two elements in the triplet would be what's associated with the 1041 in my hash table. So that would be the 366 and 675. If I do a quick sanity check, if I were to add up all three of these numbers, they would indeed give me 2020. And then to wrap up this problem, all I would want to do is take the product of three of those numbers, and that would give me my final answer over here. So that seems like a reasonable strategy to implement, and it doesn't seem that much more complicated than our last solution. That being said, let's kind of understand the time and space complexity of this one before we even code it. So let's start by analyzing the time first. So I started this solution by iterating through all pairs of elements in the array. So that would definitely be n squared. Then after I finished those n squared iterations, I made a totally separate second pass through the array. It would just give me n. So overall, if I simplify this complexity over here, n squared plus n really just boils down to O of n squared, right? Because I only take the largest term here. Now let's take a look at the space complexity. So we know that most of the space complexity here comes from the hash table. If I just analyze the keys of my hash table, I know that every single key is going to represent a unique pair sum from my original array. So if I'm looking at pair sums, I'm looking at pairs, right? So I'd really have n squared different keys of my hash table. So I have n squared different keys of my hash table, but what about the values? Well, for every key, I would really be storing two values, maybe an array or some tuple kind of structure. And so in general, I guess I can say that I have n squared keys and also two values associated with every single key. So my space kind of looks like n squared times 2, but of course, if you are familiar with some complexity analysis, I can drop the multiplicative factor here, right? So it's really just O of n squared. So overall, I'm looking at n squared time and also n squared space. It seems like a reasonable solution. Let's go ahead and implement this one now. So I have the same boilerplate as last time, so still reading the files from the same input, and the result that we should get is roughly 80 million. So again, if you're following along, you'll want to, of course, download your own input file, and you'll have a different result probably. But for me, now that I have the array of numbers, according to our strategy that we sketched out, we still need to create a set. So I'm going to do that over here. I'm going to store my pair sums in this set. And so I'll create a new set, starts empty. Now I'll begin by just populating this set with all possible pair sums. So to do that, I'm going to use nested loops, which is n squared, just over the numbers array. So just some classic syntax here. Iterate starting at I equals 0, go up to I less than numbers.length, hit every I, and do a similar thing for j to give me those nested loops. So I'll change all of these to j. That should be good to go. One thing that we might want to do for these nested loops, so I don't consider any like duplicate pairs, especially self pairs, I'm going to make sure that j begins at I plus 1. This ensures that I iterate through all unique pairs of elements of the numbers array. So as I iterate, just to be a little clean, I'll grab my num1 as numbers at index I. I'll do something similar for num2 at index j. Nice. So now that I have a pair of numbers, I want to add them as a row of my set, right? And really, I don't need a set here, or I shouldn't use a set. I actually want to use more of a JavaScript object, so I changed my mind. I need a mapping, right, from keys to values, whereas sets only have like single values. So I'll create maybe just a plain old object, I guess. And now that I have a pair, I want to calculate their sum. So I'll say const sum equals num1 plus num2. And I'm going to add this information into my object, right? So I'll say pair sums at index sum, or at the key of sum, equals an array of those two numbers, num1 and num2. So if you look at what I'm doing here, I'm making the sum of those numbers the key, and I'm making the value an array that contains both of the numbers. So at any point in time, the values of my object are going to be just an array of length 2, right? And so now that I run this part of my code, let's actually run that second pass, right? So in a separate loop, I'm going to iterate just through the numbers of my numbers array. So I could say let num of numbers. And as I iterate, I want to check if like its difference is within pair sum, right? So similar to maybe part 1, I can say calculate the difference, I'll say diff, of 2020 and my current number. And then I'll check, if that difference is inside of the pair sums object as a key, then I want to run some code. Maybe you're not familiar with this syntax for JavaScript objects. Just for some quick review, if I had an object, let me say obj equals an object where the name is, let's say Alvin, and we'll say the occupation is like, I don't know, teacher. And if I say is name in obj, that gives me back Boolean, right? True or false. So name is in obj, as well as occupation, definitely in obj. If I look for something not there, like location, that'll just return to me a false, right? So there's checking for existence in the object. So if the difference is in pair sums, then I found a triplet, right? So what I can do is grab the elements of the array over here. So if I access the value associated with that pair sum, I can say pair sums at diff. That'll give me back an array like this. So I'll just destructure that array, grabbing the elements. I'll call them maybe num_b and num_c equals that. So this is just some array destructuring syntax. Maybe that's worth going over too, right? So if you had an array of like some elements, we'll say A, B, C. What you can totally do in JavaScript is just pluck them apart one by one. So I can say let 1, 2, and 3 equals array. And then I have variables that refer to each one of those elements, right? And so I'll do the same syntax over here. And then my final move is to just return the product of num as well as num_b and num_c, right? So just multiply them together. Nothing too fancy, I think. Cool, so this code is looking pretty good. Again, we have our n squared followed by our n operation, as well as our n squared space from storing things in our object. So let's go ahead and run this. So let's see what we get. And there we have, yeah, that's the correct answer for my particular input. So there we have it. That was day 1 of the advent of code. There are probably a few different ways to solve this like pair sum or like triplet sum style problems. You could do like some sorting algorithms on it as well. This is just my preferred way. I'll kind of leave the rest for all of you. But yeah, I think we'll kind of keep this as a running series. We'll see how far we get in the days, and I'll catch you tomorrow.